Screen is visible. Hello. Hello. Okay. So I don't know. Today's strength is very less. Good morning to one and all. Today we are going to discuss that is experiment number 7. Measurement of capacitance by using shearing bridge. So we have already discussed this shearing bridge in the classroom and we have derived a derivation. Based on that, we are going to discuss the practical. We are going to perform the practical in virtual lab. We are going to do that one. Just a minute. So we are going to discuss that is the measurement of capacitance. The already we have discussed in the classroom. The main aim of the instrument, this experiment, is to measure the unknown capacitance by using the shearing bridge here. Is it audible? Anybody, can you reply please? Hello.
Yes.
Audible hai na?
Yes. Yes, sir.
So the requirements for this shearing bridge is, if we are doing the practical in offline, on that condition, the shearing bridge kit is there, that is available in the department, and that is a digital storage oscilloscope is required, unknown capacitance for the varying to make the bridge into balanced condition. For that reason, one unknown capacitance is required. The range of that one is 0.0012 microfarad to 0.1 microfarad. Digital multimeter is required to give the input voltage, how much we have to give, and to measure that one. And the connecting patch cards are required here now. Okay, so this is the circuit diagram. We have already discussed in the classroom that this is a AC bridge. Actually, shearing bridge is the AC bridge. So this one we are going to consider as Z1 here. This one Z1, this one Z2, Z1, Z2. This is Z3, this is Z3, and this one is Z4. So based on this, we have to derive, we know the formula that for the all bridge balance condition, Z1, Z4 equal to Z1, Z4 equal to Z2, Z3 here now. So here the Z1 we have to substitute, that is R1 plus 1 by J omega C1, Z2 equal to 1 by J omega C2. There is no resistance term here. Now Z3 equal to R3 and Z4 equal to XC4 and R4, both are in parallel here. Now we have to derive this equation. So after substituting this Z1, Z2, Z3, Z4 in this formula, we are going to get the unknown value. This is C1 and C2 are there. This C1 is unknown value of capacitance. This is unknown value of resistance here. So under balanced condition, we have to derive the equation. This is balanced condition. By substituting this all the values in Z1, Z4, Z2, Z3 in this equation, we are going to get the C1 and R1 equation. So manually we have to calculate the C1 and R1, and practically we are going to do, we have to compare that value with that. Okay, I will show the final equation only, because we already discussed in the classroom this one. Then also I will tell that one. So Z1 equal to, here only I told that one by seeing the formula. This is Z1 equal to R1 plus J omega 1, R1 plus 1 by J omega C1. Z4 equal to, this is Z4 equal to R4 divided by 1 plus J omega C4. This is Z4. This is Z2, that is 1 by J omega C2, and this is called Z3 here. Substituting Z1, Z4, Z2 and Z3 values in the equation number 1, this in this equation, we are going to get this equation here now. We have substituted here now. This one Z1, this is Z2, sorry, Z4, this is Z2, and this is Z3 here now. Okay, so what we have to do now, after substituting the equation, I will shift this complete multiplication factor is there. I will send this one into RHS side. It will multiply here now. It will multiply to this whole equation. So this R4 I will multiply here now. So I will keep this R1 plus 1 by J omega C1 as it is into R4. This denominator term I will send into RHS side. It will become numerator and it will be multiplied to this whole equation here now. So 1 by J omega C2 into R3, we can write R3 divided by J omega C2. We have written here, and this one whole we have multiplied here. Okay, understanding?
Yes, sir.
Next, what we have to do? Not connecting. So we have to split this equation here now. How we have to split? R1 into R4 plus R4 divided by J omega C4. This one multiplication we have to do, and this one R3 into 1 J omega C2 into 1 plus this whole term we have to by multiplying that one. We are going to get this equation here now. By rearranging the equations and all the things, we are going to get this equation, because what we have done here now, 1 by J equal to what? We already know the formula. 1 by J equal to, we can write minus J. Yes or no?
Yes, sir.
1 by J equal to, we can write minus J here now. So R4 divided by J omega C1, that one we have considered this one as minus J here. Okay, so like this we have derived here now. From this, what we have to do now? We have to separate the real and reactive terms here. Is this real term or imaginary term? This one R1, R4 is the real term. Here J is there, it is reactive. Here J is there, it is reactive. This one is a real term here now. These two real terms are there. So we can write R1, R4, R1, R4 equal to R3, R4, R3, R4, C4 divided by C2 divided by C2. Here also R1 is, R4 is there. Here also R4 is there. We can term get cancelled here now. Which is the unknown value here now? R1 is there. So R1 equal to C4 by C2 into R3. C4 by C2 into R3 हो गए. So this is the R1 equation. You note down. किधर तो note down करके रखो ये. This one. Okay. Next, similarly, by equating the imaginary parts here now, this minus J R4 by omega C1 equal to minus J R3 by omega C1. I will write same as it is here now. Then only you will understand. R4 divided by omega C1 equal to minus J R3 divided by omega C2 here. Omega C2 is there. So here minus J is there, here minus J is there, get cancelled here now. Here omega is there, here also omega is there, cancelled here. So R4 by C1 is there, R3 by C2 is there. So this C1 I will send here and C2 I will send here now. So this equation will become like this: R3 C1 equal to R4 C2 होगा इसको. Which is the unknown capacitance here? C1 is unknown capacitance. So we want C1 only. So send this R3 into here. It will become numerator here now. So C1 equal to R4 by R3 into C2 here. We have written here. Yes, we have written here. Is it clear? So we have find out the R1 formula, C1 formula here now. R1 formula and C1 formula. You note down these two equations by calculating that one. So we have to calculate the dissipation factor is there actually. Dissipation factor omega C1 R1, the formula we are going to use. C1 is here, R1 is here. By substituting this formula, the dissipation factor also we are going to get omega C4 R4 we are going to get here. Okay, so this value dissipation factor omega C4 R4, this R1 value and C1 value. Our main aim is to identify the unknown capacitance here. Now, this C1 we have to identify it. So we have to perform the practical in the virtual lab. We are going to perform that one. So this is the procedure for the offline regular when we are going to do offline practical, physical practical, and that time we have to follow this procedure. And this is the observation table. What is the value of R1, R2 and unknown capacitance, that Cx we can write, and fixed value here we have to do, and last we have to write the conclusion here. So I will show the virtual lab. It is not opening here now. Then also I have made a video based on that. I will show you people. Just a minute. So open the Google Chrome or Firefox. You have to open and you have to type here. Visible? The screen is visible. vlab.co.in. vlab.co.in. You have to enter here now. Screen is visible. So the virtual lab open, which will be created by the Ministry of Education here now. In this one, so many times I am telling this one. In this one, your broad areas of virtual labs are there. In that one, the subject actually this is belongs to the ENTC. So I will consider electronics and communication. I will click on that one. Here, analog signals, network and measurement lab is there. So search the subject name here now. Measurement lab is there. I'll click on the measurement lab here now. In this one, actually the window will be open here now. This one actually it is designed by IIT Kharagpur. They have designed that one. So next, what I do, the list of experiment we have to go, the introduction of the subject, and already we have discussed these documents. Directly I go for the list of experiment. List of experiment I'll go here now. See here, the basic electrical technology laboratories are there. This is for the basics of circuits and signals and network theorems are there here. Next, our subject is which one? Measurement. Yes, the measurement subject we have to choose here. Third option is the measurement laboratory. Total here 14 experiments are there. Out of 14, all 14 also we can do. But according to your syllabus, I am going to choose which one is there for your syllabus. The last practical we have discussed about the Maxwell bridge. Here only. Yes. Yes, sir. So now we'll go for the measurement of capacitance by sharing bridge. This is the sharing bridge.
Sir, आवाज clear येत नाही.
On this. Hello. Yes.
आवाज clear येत नव्हता सर.
Clear नाही आहे का?
हाँ सर.
एक मिनट, I will join by mobile and I will check that one. किसी का नेटवर्क सबको ऐसा है क्या? For all people it is same like this only. Hello.
ठीक से.
हाँ?
सर अभी आया सर. ठीक.
अभी आया क्या? ठीक. sharing bridge will be opened. First is here also theory part is that the same diagram we have discussed here now. The C1, R1, C2, R3 and C4, R4 are connected in parallel. In between the detector is there. The detector, it is a voltage detector we have used. Millivolt, it is going to, in the form of millivolt, it is going to display the value. The form of millivolt, it is going to display the value. So this is the circuit diagram. Same thing, whatever the diagrams I have taken the image from here. Okay, from here only they have copied all the equations. These are the R1 equation, R2 equation. You have to remember this equation. You have to note down the readings. You have to enter in the table. Remember that one here. R1, C1 values here. Okay, this is the theory part. Whatever we have discussed just now here. Now the procedure is different here. Now here we will discuss the procedure. According to this circuit diagram, first we have to apply the supply voltage from the signal generator. Signal generator से हमने supply voltage apply किया. It may be 3 volt, 5 volt or whatever it may be. Also set the unknown capacitance value from the set capacitor tab. We have to set the unknown capacitor value in the kit. It may be 0.01 microfarad, picofarad, nanofarad, all the things we can do that one. We can set that one. Then we have to switch on the supply. So unknown value of capacitance we have set it. We have switched on that one. So whatever the millivoltmeter is there, the detector, it is going to detect some voltage over there. It is going to detect some voltages in that one. By varying the other, here C1 is set here. Now by varying this C2, R4, C4, R3, we can change this one. We have to bring this one into null value. We have to bring this one into null position. We have to bring that one. We have to bring this one into 0. Once it is 0 or closer to 0, then we can say that one it is a null detector here. Now it is in the 0 operation or 0 position. Choose the values of C2, C4, R3 and R4 from the capacitance and resistance forms. Vary the values to some particular values to achieve null here. To achieve the null position, we have to vary this. Okay, next, observe the millivoltmeter pointers to achieve the null position here. That is the detector we have to observe. If null is achieved, switch to measure capacitor value, tab and click on the symbol value. Observe the calculation. We have to click this one and we will get the values of C1 and R1 value here. We have to note down that one. So this one will open the practical directly. We'll go for the simulator. We'll go that one. Before that one, actually operating system, operating environment, what is should be there? A standard computer is required. That computer should have minimum 512 MB RAM and 500 MB of space available hard disk. So 10,024 into 764 higher screen resolution should be there. The mouse or other pointing device, CD-ROM drive is required. They have mentioned that one. What is the system requirement to run this simulator? I'll click on the simulator here now, and here the diagram. All of you can see the diagram. The diagram is visible. Yes. So this is the R1 value. This is the C1 value. So you can set the C1 value into microfarad value. You have to set it. I will set this one 0.1 is there, 0.001. Can I set that one or 0.01? Later I will set that. I will set the value of 0.01. C1 value will be 0.01 microfarad. I will set that. And the frequency here 5 volt, 12 volt is there. I will set it to 3 volt. And sorry, voltage and frequency. How much I have to set? 2 50 hertz. Can I set 50? What is the Indian standard frequency? 50 hertz. Okay. I have set the voltage and frequency and this C1 value I have set it. Next, according to your procedure, this one is the unknown value. This is don't touch this part here. But by clicking clicking on this arrow, you can vary the R3 value, you can vary this C2 value, you can vary this R4 value, you can vary this C4 value. By varying these all the variables, we can bring the bridge into balance state. But this value will be in millivolt they are giving here now. Remember that one. 10 to the power of minus 3 already they are giving here. Okay, next what I will do, I will switch on the supply according to procedure. I will switch on the supply here now. So see here now, it is 0.09 value is there in the millivolt. Yes. Next what I will do, I will set the capacitor value here now. What you will do, 0.01 I will do that. Can I set the value? By clicking this one, set the value. Switch up the circuit first. Okay. Before starting the supply, we have to set the value. Click on the set. Next we have to switch on this one. और ज्यादा करेंगे क्या करें? 0.011 करें. 0.01 two readings will take that one. I will set this one 0.01. Then I will switch on this value. Here it is 0.0093 is there. Which one I have to, by varying these values, we have to increase this. We have to reduce again. Here is 93 का पहला 92 आ गए. Next 91 here. By varying this one, the value will be reduced here. Reduce हो रहा है क्या नहीं? Is decreasing now? Yes, sir. According to this procedure only I will follow here now. The beside they have mentioned the procedure. Apply the supply voltage. It may be 3 volt, 5 volt, whatever it is, from the signal generator with the arbitrary frequency. Set the unknown capacitance value from the set value for there. Then switch on the supply. Choose the values of C2, C4, R3, R4 from the capacitance and resistance bus. Where is the values? To some particular values achieve null values. To observe the multimeter pointer to achieve null are closer to null here. Some closer to null we have to achieve here. So can I vary this one also? There is no change at all. Again I will change that one. I will increase. So by increasing this one, it is happening. I will increase here 0.101. Then now I go 0.1. It is increasing. 5. Can I increase? This value is increased. 2 zeros का पहला 1 0 होना है ना. 0.001. Okay. One more zero I will add. See here. How many zeros are there here? The value is increased now, decreased. Yes or no? See here, 0.00009 milli means again 3 dots here. Now up to here it is 0 is there. 9 digits are there. You can consider this one as 0 only. Equal to 0 only you can consider. Yes, sir. So still you want to, we will increase this, we will reduce that value. See here, I am reducing. See here, not here, just a minute. 5.9 into 10 to the power of how much is that here? Minus 10 into minus 3. It is nothing but 3. 10 to the power of minus 13 over. So 13 zeros are there here, back side. 5.92 into e to the power of minus 10 means 13 zeros are there. So it is equal to 0. We can consider this point. It is equal to 0. Now what we have to do? We have the observe the multimeter pointer to achieve null or closer to null position. It is closer to null position. Now we can call that value. Now if it is achieved, switch to measure capacitor value tab here. I have to switch the tab here now. Here I will switch this one, measure capacitor value. Then here, see here. Is there any value here? C1 value display हो रही इधर? No. R1 value display है इधर? नहीं है. Dissipation factor है? No. I will click on this. See here. The capacitor C1 is 0.01. कितना सेट किया था हम? 0.01 सेट किया था? Yes or no?
Yes, sir.
0.01 सेट किया था. 0.01. The resistance R1 value is 0.0005 ohms here now. So 5 milliohms we can, 0.5 milliohms we can call them. The dissipation factor is 1.5 e to the power of minus 9. You take the screenshot of this one. This is the practical values. By considering these values of the R1, C1, you have to calculate that one here. Calculated value and observed value you have to write in the table. You have to write in the table. This is the C2 value. This is the R2, R3 value. This is R4 value. Is it clear? Here. We'll do that one. For another readings, we'll start that one. Again, I will take the simulator once again. And I'll set the another voltage value. I'll change that one. Instead of 3 volts, I will take that one into 10 volts. I will consider that. And the capacitor value I will set into 0.15. 0.15 I will set that. Can I set this one? 0.015.
Yes, sir.
Okay, I have set it this way. R also, can I change that one? That is the fixed value based on the voltage and all the things you will take. I will set here and I will switch on this one. Here 0.46 is there. Next what I will do, how to reduce from by using these things. By increasing the resistance, what will happen? Okay, it is increasing here. Just see 0.000 आ गए. There is a small change. थोड़ा भी change होगा ना? It is there here, almost null. Detector 0.00000. Is there or not?
Yes.
Here to the null position. Next, what I will do? I will measure the values here now. I will click on the simulate here now. Simulate here. See here. Capacitor value is setted value is 0.015. Measured value also give away. Our resistance value measured is 0.04 and 1.88 is the dissipation factor. To take the second reading value. पहला सेट किए वाला, अब ये कैलकुलेशन किए वाला, measured values. All the things. We'll take one more reading. One more reading लेना है. If you want to take one more reading, just switch off the supply. Change this capacitor value. Again, you go to the set value, set capacitor value. इसको 0.05 कर देंगे. 0.05 I will set that one value. 0.15 नहीं. And the voltage is 8 volt. I will set here now. 50 hertz रहने दो. I will click on it. Here by varying this one, you have to increase. One layer. How to increase here. Resistance.
Sometimes it is increased, sometimes it will decreases. Here 0.001 is there. I will decrease calculation. Click on it. It will maybe 10. Yes, maybe 2, 20, 100. Sorry. So it is not changing at all here now. This is a 0.0010. This much is enough into 10 to the power of minus 3 is there already. 10, 9, 10.
So 3 readings we have displayed here now. Yes, already you have taken 3 readings. This is not new. Already I told that one vlab.co.in. By visiting that, you can practice in your mobile by using a Google Chrome only. It will not open in a normal web and all the things. It will open in a Google Chrome only. So according to it, you practice it and you can check the readings. And by seeing this video also, I will upload the video and I will already link will be provided in the teaching diary. Okay, you can view that one and you can complete the write up part here. So experiment number 7 is completed. Okay, so only one more experiment we have to do, that is 8th experiment, measurement of voltage, current, resistance by using digital storage oscilloscope. So 5th is your exam is there, yes or no? Hello.
Yes, sir.
For that reason, we should not waste the time. Another half an hour time is there. In that period, I will complete the 8th experiment also. That is actually in the live video I have recorded. That video I will play here. You can see that one. Okay, just a minute. So experiment number 8, that is I'm going to share with you. You can check that one. Visible?
So the last experiment, that is experiment number 8.
Okay.
We are going to discuss, that is very easy experiment. Already we have done this experiment also. Rather done the practical on this also. Measurement of various parameters using oscilloscope. Actually, it will comes under 8th range. So the theory part of oscilloscope and all the things, no need to worry about that. Don't consider that. Okay. So the title of experiment is measurement of various parameters using oscilloscope. To measure the various parameters like voltage, current, frequency, and time period using oscilloscope, we can measure the voltage, current, frequency, and time period by using the oscilloscope here. So to do this experiment, to perform this experiment, the main required things are apparatus here. So the apparatus is nothing but, that is the oscilloscope is required. So we are going to use a DSO, that is called digital storage oscilloscope. Whatever the values is there, if we have connected to computer, means automatically it is going to store over there. So DSO, digital storage oscilloscope, we are going to consider. To connect that one, connecting probes are required. The function generator, which one we are going to use, do the supply to that DSO here. We get the output here. So instead of explaining this all the theory, I have to go to that monitor only direct. So procedure, before procedure, I will take the observation table and diagram. Diagrams are there. Okay. The observation table, what we have to measure here now. So DC voltage and current here now. AC voltage, DC voltage, current, time period, frequency. These all things we can measure, but we don't have function generator. So DC voltage, and by adding some resistance, we can measure the current also. We can measure the current also, we can measure here. So we are going to discuss here AC voltage, how to measure the AC voltage, time period, frequency, peak to peak value, minimum value, V minimum, V maximum, V RMS, all the things we are going to discuss here. Today we are going to measure that one. V RMS, V max, and all the things we are going to discuss in the today's laboratory. To perform this one, to do the practical of this one here, procedure will go directly. I will go to the procedure here now. First one, that is called voltage measurement, DC voltage measurement here now. To trace the horizontal is adjusted with that is lie on the x-axis here now. See, all of you know very well about that one. The DC is nothing but direct current here. Here, suppose I have in the graph, I have taken this one as 0 here now. Then the value will be straight line here. The straight line we are going to consider, that is called DC here. Okay, that is called DC. Okay, so this value, how much is there here? It is 1 or 2 or 3 or 4. We are going to measure here. This will give the value of DC voltage or DC current. That one only they have written here, no DC value here. Okay, if we have considered this is reference value, this one is reference, then suppose if I got the value here means that is minus DC value, it is in the minus value. That is DC value in minus here. So it is minus. This one reference here now. We have considered this one as a reference. If it is there, this is plus DC value, this is minus DC value. The shift of trace from the horizontal axis, which give the measure of magnitude of the DC voltage, we are going to call that. That is called magnitude. Next one. So the AC voltage. AC means what? Anyone, can you tell me the AC? Long form of AC?
Alternating current.
Alternating current. Alternating current means it will consist of both positive and negative half cycle. Actually, DC and all the things, there is no much thing to learn here now. But here, for the learning method, this is the very important thing we have to consider alternating here. See here, this is the value of the positive half cycle. This is the value of negative half cycle. Positive half cycle, negative half cycle, positive half cycle, negative half cycle. Alternating quantity we are going to call it. Okay. So from this point, whatever this is there, this one, it is a maximum. We are going to consider that one. V max, we are going to call that one. V max it is. V max. And from this point to here, the upper point to the lower point. That is, this one is V max, this one is V minimum, or minus V max. We are going to call this. V max and minus V max here. That is positive side, and this is negative side here. Maximum and V minimum, V max here. Plus V max, minus V max. That is called, this is the peak value. This is the minus side peak value. So peak to peak here now. That is called peak to peak voltage. We are going to call that. Peak to peak voltage. And this one is only peak voltage or maximum voltage. We are going to call it. Peak voltage or maximum voltage, we are going to call that one. So what is the formula for the what is that we are going to call VRMS? All of you have studied the first year. In the first year, VRMS equal to 1 by root 2 into, or VRMS equal to Vmax by root 2. Yes, you have studied this formula. Vmax by root 2, na?
Yes, sir.
So
Yes, sir.
RMS value indicates the AC voltage here. No? The RMS value indicates AC voltage. That is called Vmax by root 2 here. Now that is called AC voltage. It is going to do, and this is peak to peak value we are going to measure here now, and peak value and the time period. Time period is very important. Actually, they have mentioned here voltage value. They have mentioned if we know the value of resistance. Then voltage, whatever the voltage we have measured, divided by 5 ohm, the current value we are going to get. According to Ohm's law, current equal to voltage by resistance. Yes or no?
Yeah.
Current equal to I equal to V by R. So by reducing that value, so So by dividing by resistance value, we are going to get the current value. We are going to get the current value. So one more important thing we have to discuss here now. Where it went? Okay, here. The time period also. The time to complete one half cycle here now. That is called T. We are going to call here. एक half cycle complete करने के लिए कितना time लेते हैं ना? That is called T. Time period we are going to call that here. From here to here. 0 to this 0. 180 degree we are going to call that. Not complete full cycle. So full cycle means one positive half cycle, one negative half cycle. That is called 2T we are going to call. 2T. Actually, the time period means the time taken to complete one half cycle is called time period, and the reciprocal of time period, it is nothing but frequency here. Now, by using this method, we can measure the frequency here. We can calculate how many time period is how much, how many time here it is the seconds in we are going to get here now. That if f equal to 1 by t, by doing this one also, we can measure the frequency here. So our main aim, what we have, because they are joining now. So already in the EDC subject we have shown, sir has shown the DSO. DSO देखा है ना already? Digital storage oscilloscope. Yes.
Yes, sir.
So the serial number, AC voltage I am going to show, but DC voltage randomly I will give the reading here now. We can write down the current by considering 5 ohm resistance, 10 ohm resistance, and 15 ohm resistance. 3 voltage you can measure here. Only 2 readings I will give. And time period you can note down, and according to that frequency also I will show you people in the display of that practical. Okay, just a minute. I will join by mobile and I will go to the kit.
What happened to this? Just a minute.
The last experiment today actually.
The screen is rotated.
So what I will do, I'll stop sharing here. To note down this table, observation table.
Just a minute. So directly we'll go for the DSO.
This is called digital storage oscilloscope here now. See the name it is showing here, digital oscilloscope. It has 2 channels here now, channel 1 and channel 2. Here they have a cursors are there. We can acquire, we can save or recall the value, we can measure, can display the value, you can do the utility values also, can run, stop, single. This is for the horizontal movement, and this is for the vertical movements here. Up and down is the horizontal position we are going to use. Okay, I'll switch on, sees all the things, and here I'm using one transformer, that is okay 232, I think 13 and 20 volts. Step down it is going to do here now. Okay, some leakage is there. Here I have connected the probe here now. I am going to use the channel 1. I have connected the probe here now. I will remove this probe also. No need to worry. This is the probe we are going to consider. One we have to do the positive connection, another one for the negative connection. Okay. So I will see here 3 terminals are there. I will take these two terminals I will take. First I will connect to the for the positive. I will do the connection here now. It is connected. For the another terminal, I will do the connection here. Okay. I will switch on the supply. Both. I will switch on. Both I will switch on that one. Here. The alternating voltage we are going to measure here now. The alternating voltage we are going to measure here now. I told this knob is for horizontal here now. You can spread this one like this or like this, like this here now. You can take the position also, this one. By varying this one, we can shift into left and right also we can shift that one. It will indicate here now center point here now. I'll keep the term as center here now. For the vertical position, we can do like this here now. It indicates here this one. This is center point. This one. Okay. So what we have to measure? We have to measure the AC voltage, time period, frequency, and current. We can do the calculation. For 5 ohm, 2 ohm, 4 ohm, and 5 ohm. 2 and 4 ohm we can do that one. I have not added here the current. Okay. Here a run option is there or stop option is there. Okay. And here the measure is there. We can press the measure button here now. Okay. What it told here? What is it displaying here? What it is showing? Voltage, time, delay, all measurement. Yes. Okay. See here. I told the knob probe is connected to the channel 1. You can if you press it like this, it is going to trigger or off. It is nothing but display again. Avi. Now we have to trigger it here now. The channel 1. If you press to channel 2, see channel 2 the reference line it came here now. Reference line again, channel 2 ka? You can do that one. We can take this one as a reference here. So I will not take any reference line. I will cancel that one. Only the channel 1 I have set it here now. You can increase this position here now. How much it is there? This the period it will indicate that 10 volts. You can do that one here now. You can reduce less than that also. You can reduce that one. Here 2 volts. It is, but it will not sit at the upper circuit event. 1 slot equal to 5, 48 balance. So like this only I will keep here now. Like this I will keep here now. What we have to measure? Measurement क्या करना है? VRMS AC voltage. Yes. So what I will do, instead of doing calculation and all the things, I will press here the measure button is there. Is there or not here? Measure. Yes. Measure is there?
Yes, sir.
I will press this one. Here, voltage, time, delay, all measurements and clear measurements is there. What I will do, I will take all measurements here now. I will take all measurements. In that one, first I will take the voltage here now. See here, it is displayed here now. This is called channel number 1. Maximum V minimum is nothing but minus 19.6. Base value is 19.2. VRMS is how much it is there?
13.20.
13.2 is our voltage. I will prove that one here. Kitna hai voltage? We can check that one. And here for E, leave that one. The VPP is nothing but peak to peak voltage. How much it is there? Peak to peak. 39.6 here now. And V amplitude is 13.8. V measurement 0. C RMS, that is capacity RMS, and V max here now. See 19.6. It is moving now.
Yes, sir. Moving. Change.
Over and changing it is. But just a minute. I will stop this one here only. Yeah, it will stop that one here now. You note down the value of VP. VP is 20 volts. Okay, VPP is 39.6, is approximately 40 you write down, peak to peak. VRMS equal to 13.2 here. So Vmax divided by root 2 करो कितना हो जाता है देखो. Vmax divided by root 2. $14 हो गया क्या? Yes or no? Do that one. Okay. Here our aim is AC voltage you have to measure. Yes. 13.2. AC voltage I have to measure. See here, by using the multimeter also, I will show that one. I will check that one. Kitna voltage I will get. I will show you people. Here the multimeter is there. We have taken for the DC auto. Okay. For the AC auto, I will check here. Okay. I will connect here. One row. कितना है देखो? How much it is there? 0.5. Just a minute. अभी fluctuation है थोड़ा. $13.4 or 13.2. Here only it is varying. Yes. Variation is there. Na? Just a minute. Overage sir 1 मिनट आओ ना. कैमरा होल्ड करो एटलीस्ट. Here I have stopped here now. कितना है? 13.5 or 13.4 here now. So that is called AC voltage. You note down AC voltage. AC voltage you have to note down here now. And one more thing, I will off this one here. How many digits are there here? How many blocks it has considered? One block and two blocks here now. Channel 1 it is visible here now. Channel 1, one block it is nothing but equal to 10 volts here now. Here it is that 10 volts is the channel 1. Yes.
Yes, sir.
So here from the reference you consider this one. This is the center point here. So it is one block and second block here. For the second block, 10 plus 10, how much it is? Nothing but
20.
So Vmax equal to 20. It is displaying here. Vmax equal to 20. Is that 20? Yes. So that is peak value is 20 only. Peak value is 20. So upper side 2 blocks it has reached. For the lower side 1 and 2. Again 2 is there. So peak to peak here 20, here 20. How much it is the total peak to peak value? 40 only, na? I'll show the peak to peak value here. No? Here 39.6 something we got here. Yes. VPP is the peak value. So VRMS equal to 13.2. We are measuring here now. Okay. This voltage you have write down here now. Next I will show the time period and frequency here now. See here. Here what is there here? Time. Showing the time? Yes. So I will click on the time on. I will make on the time here now. Here now. So the time period is 20 millisecond is there. 20 millisecond. So the frequency is 50.01 hertz is there. The time period it is nothing but here 1, 2, 3, 4 here now. 2 x-axis it is nothing but here. This is 10. This is 10. It is considering like here now. 2 blocks are that here now. 10 plus 10 it is nothing but 20 milliseconds. In milliseconds we are going to consider. If t equal to 20 milliseconds, 1 by 20 milliseconds, how much calculate करो कितना आते देखो value 1 by 20 milliseconds. Millisecond means 1 by 20 into 10 to the power of minus 3. कितना है आंसर? How much you got? Yes. It's nothing but upper side 0.05 into 1000. How much it is? 50. Yes. You got the value or not here now? 50.
Yes, sir.
The frequency is 50 here. So we have measured the whatever the voltage is the VRMS. That one I will display all the values I can display here. The voltage, current, time period. All it will going to display here now. It is going to display here now. Here one more option is the print. By connecting USB, if you connect to the computer and you can print also readings. सब लोग I think किधर तो देखा है क्या आप लोग? Anywhere you have you seen this one? कहीं तो देखा है क्या? I will tell later. किधर देखा होगा शायद. हॉस्पिटल में देखा है क्या ICU में? सब मूवी में दिखाते देखो ऑक्सीजन. This oscilloscope only. Okay, this is one reading. Next, what you will do? Off. Okay. Next, what I will do?
So listen here now. We have discussed about this digital oscilloscope storage. Okay, it will be comes under chapter number 6 here. So just we have shown the demo lecture here now. Just whatever I have shown the readings, you have to write down in the tables over there. Okay, already I have uploaded the lab manual in the teaching diary. You download it, you write all the experiments. Okay, explain the teaching diary. I have given the link also. Each lecture link I have given, even experiment number, name and title also I have written over there. So this completes your practical of EMI subject practical. It is going completed now. So for the next we'll concentrate on only theory syllabus only. So already 4th unit, in another 1 hour it is going to complete. We'll see the 5th and 6th unit. Okay, so my request is that you complete the write-up part, lab write-up part. You complete this one. This subject has practical oral examination for 50 marks. So you have to prepare for the oral examination here now. The external will come. You will ask the questions. You have to give the answers. According to that, your marks is going to display. Okay, we are going to give that one. And 25 marks term work is there. For that 25 marks, it will matter. Your attendance will matter. Your ISC marks will matter, and your chapter test marks and your lab manual. Okay, who will give the lab manual submit lab write up here now? So all of you keep ready here now. When you are going to submit the lab write up, you only tell the date. I'll post the link in the group. कब सबमिट करने वाले लैब राइट अप कब सबमिट करते बोलो मेरे को. Hello, is it audible or not?
Yes, sir.
What is the date you want?
18.
18. Okay. On 18th, I will put the link. All of you upload the lab write up on that one. Okay. We'll stop here only.